8 is the system of equations and inequality. So before we start our chapter, let's review our 2 by 2, which means you have two variables and two equations. So if you have a linear equation, it's going to be a line, all right? So the line, if you have two equations and two variable, the line can cross at one point. So let's say it's crossed at this point. You can have coordinate x, y, and this point should satisfy both equations. So this is called independent system. You have only one solution, and this point x, y is the solution for both equations. If you look at the graph, this graph is going down, so the slope should be negative, and this one slope should be positive. So these two graphs will not have the same slope. So the slope will be different. Right? Slope will be different. And y-intercept. So if you draw a vertical line, let's say you have a vertical line here, is the y coordinate. So the y-intercept will be different. They will cross y at a different point. So the y-intercept will be different. Now, if you have two lines, they can also be parallel. So when they're parallel, they never cross. If they never cross, so no solution, because we don't have a point that they share. This is called inconsistent system. And if you solve the equation, you're going to have a false statement like 5 equal to 2, 0 equal to 9, something that's not true. So is inconsistent system. And the slope, if you look at the line, slope is going to be the same because they're parallel. So the slope will be the same. Now, if you draw a vertical line, think of it as the y coordinate. The y-intercept will be different. Look at the last one. The equation could be different, but actually it's the same. So they're on the same line. So they cross everywhere. Since they cross everywhere, it's infinitely many solutions. So it's so many points on this graph. And if you solve the equation, you will have a true statement. For example, 0 equal to 0, 2 equal to 2. So if that's the case, it's called dependent system. And they're on the same line. So the slope will be the same, right? The slope will be equal. And y-intercept, if you draw a vertical line, it's going to be the same. So let's look at more example. The first one, I'm going to use the substitution method. The second and the third one, I'm going to use elimination method. Which method should you use depend on your problem. Look at the first problem here. I have 2x minus 3y equal to 7 and x equal to 3y minus 1. It's best to use substitution method because they solve for one variable for you already. In this case, they solve for x. You just substitute the x in the other equation, then you get the y or the x. So let's do the substitution method here. So I'm going to substitute x equal to 3y minus 1 into the first equation. So I'm going to have 2. Instead of x, I'm going to put 3y minus 1 minus 3y equal to 7. By doing substitution, your x variable disappear. You only have y. Now you just solve the linear equation. Distributive, you have 6y minus 2 minus 3y equal to 7. Combine like term, 6y and minus 3y is 3y. Add 2 to both sides, I got 9. So y divided by equal to 3. I divide both sides by 3. So y equal to 3. Now you get the y. You substitute y back in either the first or the second equation to get your x. Pick the one that you're comfortable or easy. So I'll pick the second one right here. So x would equal to 3. Instead of y, I put 3 minus 1. So x equal to 9 minus 1 So x equal to 8. So basically, this is the point that the two graphs cross. Is the first one is independent system, and the solution is 8, 3. All right, the solution is 8, 3. The first coordinate is the x, the second coordinate is the y. And if you substitute this point into both equations, it should satisfy. All right, so this is independent system. All right, let's look at the next one. I'm going to use the elimination method. Elimination method is that you're going to eliminate one variable. Let's try to understand this. If you have 2x, you want to eliminate the 2x, you need the negative 2x. So it end up be 0. If you have 9y, you want to eliminate this, you need negative 9y. So it's 0. That's the whole idea of this. And we all can do different things and think different. So first thing I'm going to do, I don't like the fraction. I'm going to get rid of the fraction. So the first equation here, LCM is 15. All right, I'm going to multiply everything by 15. If I multiply the left-hand side by 15 and the right-hand side by 15. All right, so let's see what happened. The reason I do that, I want to get rid of the fraction. So 3 go to 15 5 times, so you end up with 5x minus 3y equal to 30. Let's call this equation number 3. All right. I have 5x here. Let's say I want to eliminate x. I have 5x here, negative 10x here. So if I have 10x here, the x will disappear. So what I'm going to do, I'm going to multiply the third equation by 2. Right? I'm going to multiply this equation by 2. So I end up with 10x minus 6y equal to 60. That's equation number 4. See equation number 2, I'm going to rewrite it this way. Negative 10x plus 6y equal 25. That's equation number 2. I want to line up the x, line up the y, line up the constant. Just is easier for me. So 10x cancel. So I have 0 is equal to 85. 0 doesn't equal to 85. So that is contradiction. So it's false statement. It's false statement. So it means these two lines are parallel. Is no solution. And is inconsistent system. Let me double check. Yes, that's correct. All right. So you have a false statement, no solution, inconsistent. If you draw a graph, it should be a parallel line. Let's look at the next one. Again, I'm going to use elimination method. Again, let's say I want to get rid of the 2. I don't like fraction. So I'm going to multiply every term by 2. So then I'm going to have 10x plus 35y equal 50. All right, and multiply everything by 2. No, 20x. Now it's correct. All right. Now I have this one because I don't have much room. Let's see. I'm going to multiply by negative 5 because I want to get rid of y. Let's say I'm going to multiply by negative 5. All right. Negative 5 times 20 is negative 20x. Negative 5 times 7 is negative 35y. equal to negative 50. All right. So I'm going to combine these two. What do I have? Cancel, cancel, 0 equal to 0. It's true, right? 0 equal to 0. So this is a true statement. It means that it's on the same line, infinitely many solutions. So let's say one of solution will be x. So if you solve for x, you can pick one of them and solve for y. Let's take the first one. Let's say if I have 4x plus 7y equal to 10. I want to solve for y in terms of x. So 7y would be 10 minus 4x. So y will be 10 minus 4x over 7. So my y coordinate would be 10 minus 4x over 7. So depend on x, you can have different y. That's why it's infinitely many solutions. Let's look at 3 by 3. Hi, let's continue our next section. Now I extended instead of 2 by 2, now I have 3 by 3, which means I have 3 variables, x, y, and z. So basically you have 3-dimensional. So let's look at the first one. You have 3 planes, and they can cross at one point. This is the point that they cross. So when you solve it, you're going to have x, y, and z. So it's one solution. Now, sometimes they don't cross at all. It could be, this would be one way that they on top, they're not really crossed, but they're just parallel. So there is no solution. It can be also so many, infinitely many solutions. It means you can have 3 pieces of paper on top of each other, like this. Or you can have 3 pieces of, 3 planes or 3 pieces of paper, and they cross. This is the line. It's become a line. The line here is the or the point that they cross. So if you have a line, it's infinitely many solutions. All right. So to solve 3 by 3, all right, you need to use both elimination and substitution method. You're gonna start out with elimination and then substitution method. So first thing you need to do, you need to line up the x, all right, line up the y, line up the z, and line up the constant. If they don't line up for you, you need to do that. So you're gonna eliminate one variable at a time. If you want to eliminate the x, you have 2x here, you might want a negative 2x here. Or if you have 3x here, you might want negative 3x here. We all think different, and we might do different things, but we should get the same answer. I decided I'm going to eliminate the z because I have plus c for the first equation. I have minus c on the second equation. I know that if I add the first and the second equation, my z will disappear. So I make a note to myself. This is mean the first equation over here, and this is the second equation over here. And I line up the x, the y, the z, and the constant. So it's easier to see, just organize it. So if you add these two equations, the x, you have 1x here and 2x here, it's going to be 3x. The y is going to be plus 4y. The z plus c and minus c will disappear, so you're going to have 11. So let's call this equation number 4. All right. Now I eliminate the z. I have to pick another pair to eliminate the z again. So I pick the first one, I pick this 2. I have to pick different pair. So I decide to multiply the second one by 3. The reason I do that, if I multiply the second one by 3, I have negative 3, and positive 3. I will eliminate the z. So I make a note to myself, equation number 2, all right, multiply by 3. So if I multiply the second equation by 3, I'm going to have 6x plus 9y minus 3z equal 15. 6x minus plus 9y minus 3z equal to 15. That's called equation number 5. Alright, that's equation number 5. Because I want to eliminate the c, I'm going to add 3 and 5. Alright, remember I'm adding these two. Okay, 3 and 5, 3 and 6 is 9, 9x. Y, I'm going to have plus 7y. The plus and the minus 3c cancel out. And then I'm going to have 23. That's equation number 6. Alright, I eliminate the c. You can see these two equations here. Now, if go back to the last section, 2 by 2. Now I have just x and y. So let's say I want to eliminate the x. Alright, I want to eliminate the x. If I want to eliminate the x, I have 9x here. If I have negative 9x here, I can add them. So what I'm going to do, I'm going to multiply equation number 4 by negative 3. So I make a note to myself, equation number 4 multiplied by negative 3. So I'm going to have negative 9x, negative 12y equal negative 33. So let's call this equation number 7. All right. I'm going to add 4 and 7. Why do I? Oh, I'm sorry. I'm going to add 6 and 7. Why do I do that? To eliminate the x. Add 6 and 7. So I make a note to myself. 6 plus 7. So I have the x just cancel out. So I left with negative 5y is equal to negative 10. All right. Then I'm going to divide both sides by negative 5. So my y will be 2. I get my y. So I have to substitute. Now I have to use substitution. Substitute it back and get your x and then your z. So I have my y. I need to go back to the two variable. I have two variable here, here. Okay, so it doesn't matter which one to pick. So I'm going to substitute y equal to 2 in equation number 4. I pick equation number 4. You could have picked 6 as well, but I pick 4. So I have 3x plus 4. Instead of y, I put 2 equal to 11. So 3x plus 8 equal to 11. 3x equal to 3. X would be 1. I got my x. So next I'm going to do, I have my x, I have my y. I have to go to the one that have 3 variables. It can be 1, 2, or 3, whichever you prefer. Substitute x, substitute y, and get your c. So I'm going to substitute x equal to 1, y equal to 2, and that's it in equation number 1 over here. All right, so I'm going to have x plus y plus c equal to 6. X is 1, y is 2, z we don't know. All right, so it's 3 plus c equal to 6, so z equal to 3. So these 3 equations cross at one point, like the first one, and the point that they cross is in this order: 1, 2, and 3. X, y, and c. You have to put in that order. So it crosses at one point. Now, if you solve it and you get a false statement, for example, 0 equal to 5, stop. No solution. It means it's a parallel, like this one. If you solve anywhere at the beginning and you get something like true statement, 0 equal to 0, 9 equal to 9, it's just stop. It's just say infinitely many solutions. All right, let's look at the next section.